This is a real brief lecture on balancing chemical equations, just with a few tips that should help you. Just a quick review to make sure you are familiar with the different parts of a chemical equation. Reactants are to the left of the arrow, products are to the right, and these little lowercase letters that are in parentheses, you probably are familiar with these, are the state of matter, solid, gas, and let's see, solid, liquid, gas, and aqueous. Aqueous means actually dissolved in water. A reaction must be balanced according to the law of conservation of mass. And do you know what you're actually balancing when you balance a chemical reaction? You are balancing the number and type of each atom. Okay, so I've seen standardized questions before that, give you a multiple choice and suggest that you're balancing molecules or moles. You're not, okay? You can often have one molecule as a reactant and 3 or 4 molecules as products. So it is the atoms that you're balancing. What you may not be aware of is you are also balancing the mass. The law of conservation of mass says that you cannot create or destroy matter in a regular chemical reaction. And so that what that means is that the total mass of the reactants must equal the total mass of the products. And so that might be an easy little multiple choice question too, where, for example, you're given the mass of each of the reactants and you're given the mass of only one of the products and asked to solve for the mass of the unknown product. And so it's just simple math. Okay. Onward. All right, so when you are balancing chemical equations, the only tool you have, the only thing you can change are the coefficients, the large numbers that are in front of each substance. Never, ever, ever change the subscripts. The subscripts define what the substance is, and if you change that, you're making a new substance that probably doesn't even exist in that reaction. So, for example, if you had the reaction hydrogen gas and oxygen gas, we know that nature, when they combine those two, it makes water. It could be real tempting to say, I'm just going to put H2O2, then everything's balanced, right? No, because H2O2 is not what this reaction makes. So, again, never touch the subscripts. Alrighty, so there are a list of what you should balance first, second, third, etc. And this really works. If you have enough self-discipline to follow this list, you will be able to balance everything. Okay, so first, balance metals. Remember, the metals are anything to the left of the stair step on the periodic table. Then balance polyatomic ions, and balance polyatomic ions as an entire group. So, for example, the sulfate polyatomic ion. If you see that in a reaction, you ask yourself how many sulfate groups are on the reactant side and how many sulfate groups are on the product side. Don't break it into the individual atoms like sulfur and oxygen. It gets way too complicated. All right, so probably the most important rule is don't balance oxygen until last. It's always the troublemaker. And balance hydrogen next to last. All right, this is a really easy one. So you can try it on your own if you want. I would suggest doing that, actually. Just turn the video off for a second, give it a shot on your own. All right, so again, you want to balance metals first. So there are 2 aluminum on the product side and only 1 on the reactant side. So again, the only power I have is these large numbers, the coefficients in front of each substance. All right, and then all that's left is bromine. We have 6 bromine atoms on the product side and only 2 on the reactant side. So how do I get 6 on the reactant side? They have to be equal numbers. If I put a 3 as a coefficient. Now, if you have coefficients and subscripts, you multiply them by each other, okay? And everything's balanced now. And so if you're left with no coefficient in front of something, it's presumed to be a 1. Okay? That was a really easy one, hopefully. All right, here's one that's a little more challenging. This is the combustion reaction. So if you're not familiar with combustion reaction, you should get familiar because they're real common reactions. But you will always have some type of, typically a hydrocarbon fuel. It's like gasoline or candle wax. All those are hydrocarbons. Then, of course, I'm sure you know that when you burn something, you need oxygen gas. The products of combustion are always the same, always carbon dioxide and water. So my tip for balancing combustion reactions is balance the atoms in alphabetical order. Carbon first, then hydrogen, then oxygen. So CHO. All right, so let's do this. We have 3 carbon on the reactant side and only 1 on the product side. So I'm going to put a 3 here. That gives me 3 on both sides of the arrow. Then I'm going to do hydrogen next. Remember, you're going to save oxygen till last. Hydrogen, we have 8 on the reactant side and only 2. So what do you multiply 2 by to get 8? All right. So now, the part that messes students up in balancing combustion reactions is that they forget there are 2 sources of oxygen on the product side. So don't forget, when you're counting total number of oxygen atoms, you got to count both of these. All right, and you also have to remember to multiply subscripts by coefficients. So carbon dioxide provides 3 times 2 or 6 oxygen, okay? And this water, again, we presume that's a subscript of 1 with the oxygen. 4 times 1 is 4. So we have a total of 10 oxygen on the product side. So we need that same number of oxygen on the reactant side. Okay, so if we put a 5 as a coefficient, 5 times 2 is 10. All right, so everything is balanced now. And again, if you're left with a blank, it's just understood to be a 1. That is it. Again, I would suggest trying this one on your own. So shutting off the video, and then I will go through it. You can check your answer. All right, so start with the metals. Silver's the only metal. There are 2 here, so I'm going to put a coefficient of 2. There is a polyatomic. There's 1 SO4 group in the reactant side, and there's 1 SO4 group in the product side. So that's already balanced. I'm going to leave that alone. And let's see, chlorine comes next. I have 2 chlorine on the product side, so I need to put a 2 here. The only atom I haven't looked at yet is hydrogen. So I have 2 hydrogen atoms on the reactant side and 2 hydrogen atoms on the product side. Everything's balanced. That was pretty easy too. All right, so here are some challenging ones. If you're feeling confident, well, I would recommend shutting off the video because I will tell you right now there's a little aha moment. Like you're going to stop and say, wait a minute, this isn't right. What can I do? So I challenge you to try to figure out how to balance these on your own, and then I'll walk you through the way I do it. All right, so hopefully you can recognize this is a combustion reaction. So CHO, carbon, then hydrogen, then oxygen. So let me show you the little glitch here. There are 4 carbon on the reactant side, so I'm going to put a 4 in front of this carbon. And I'm going to balance hydrogen next. There are 10 hydrogen on the reactant side. If I put a 5 here, 5 times 2 is 10. And all I have left is oxygen to balance, right? So I start out by counting the total number of oxygen I have on the product side. So let's see, 4 times 2 is 8 oxygen from carbon dioxide, and 5 times 1, 5 oxygen from water. So I have a total of 13 oxygen. Uh-oh, how do I get 13? That's an odd number when it's O2. So there are 2 easy ways to take care of this. You cannot leave a fraction in in a balanced reaction. Can't leave it as a fraction, okay? It should be whole numbers. All right, so one thing to do is to take the number of oxygen over 2, so 13 over 2. That's just temporary, okay? And so now it's balanced, but it's using a fraction. So how do you get rid of 13 over 2? What do you multiply it by to make it a whole number? By 2, right? So you would have to multiply everything, all of your coefficients by 2, so that your mole ratios are still the same. Okay? So when I multiply them all by 2, what do I end up with? Let me pick a different color here so we can tell what's what. All right. So that would give me 2 C4H10, 13 O2, 8 CO2, and 10 H2O. Now I'm going to show you another way to balance these, which my students tend to prefer. It might be easier, so. All right. And that is, if you get to the point when you're balancing a reaction, it happens pretty frequently actually, when you realize that you're going to have a fraction, or if you get to the point where you just can't balance a reaction, what I recommend is erasing everything you've done and start over fresh by putting a 2 in front of the first substance. Okay? So now let's go through all the steps again. How many carbons do we have in the reactant side? Well, now we have 2 times 4, or 8. So now I'm going to put an 8 here. How many hydrogen on the reactant side? 2 times 10 is 20. So I'm going to put a 10 here so that I have 20 hydrogen on the product side. Now I need to count total oxygen on the product side again. So 8 times 2 is 16. 10 times 1 is 10. So now I have 26 oxygen on the product side. And how do I get 26 on the reactant side? See, now I can do a whole number. Okay? So again, if you reach a point where you just can't seem to balance something, you realize you're running into fractions, go ahead and put a 2 coefficient in front of the first substance and go through all the steps again. All right, so hopefully then you can do this one on your own if you didn't do the combustion on your own. So give that a shot, and so I'd turn the video off and then come back and I'll have the answer filled in for you. I'm going to cheat because I know that needs to be a 2. All right, so those are the coefficients. Hopefully you came up with those on your own too. All right, this is the most challenging. So I don't know if you're like my students, but they've gotten rusty on converting names to actual formulas. And so before you can balance this reaction, you have to get the formulas correct. So I'm going to give you a quick little reminder because that's probably something everyone needs practice on. These are all ionic compounds. How do I know that? Well, they all start with the metal, okay? And that tells me right there they're all ionic compounds. If, in order to come up with the correct ionic formula, it's a 2-step process. So you have to start out by writing the individual ions with their charges. Okay, sodium's in group 1, so it's got a charge of +1. Phosphate is a polyatomic ion. We know that because of the ending ate or ite. So look that up if you need to, if you don't have it memorized. Okay, and then do your crisscrossing of charges. And so sodium phosphate looks like this. All right, iron oxide. Iron. Now the Roman numeral tells us the charge of iron. And then oxide, that is just oxygen. And oxygen is in a group in the periodic table that when it's an ion has a charge of -2. Crisscross those. And the formula for iron 3 oxide is Fe2O3. Alrighty, and let's see, sodium oxide. I'm going to do the products here. So there we have sodium and oxygen. And when we crisscross, we get Na2O and iron phosphate. So iron is +3, phosphate is -3. So anytime the cation and anion have equal but opposite charges, just put them together in a 1-to-1 ratio. All right, there we go. All right, so now we can balance. All right, so as always, we're going to start with the metals. So we have 2 metals this time. We have sodium and iron. I'll just start randomly with sodium. There are 3 sodium on the reactant side, and there are 2 on the product side. What do I do about that? In that case, you want the lowest common factor. I usually start off by just multiplying them by each other and making them both equal to that. So 3 times 2 is 6. So I make 6 atoms on both sides. So if we put a 2 here at 6 sodium, 2 times 3 is 6. And then I would put a 3 here. 3 times 2 is 6. All right, so the sodium atoms are balanced. There's another metal, and it's iron. We have 2 iron on the reactant side and only 1 on the product side. So I'm going to put a 2 here. Then we need to balance polyatomic ions next. We have 2 phosphate groups on the reactant side. And fortunate for us, we have 2 phosphate groups on the product side. Yay! So what do we have left that we haven't balanced? Only oxygen. Now make sure you don't balance the oxygen that's part of a polyatomic. You already balance the polyatomics, so you ignore these. So ignoring the polyatomics, we have 3 oxygen on the reactant side, and yay, 3 oxygen on the product side. Everything's balanced now. We are done. And that's it for this lecture.